going to work is, if you look at the top on the first page, you know, it says review together, so I'm going to do that one with you. Then you're going to try it, and I'm going to walk around. I'll give you like a piece of paper to initial, and we'll raffle off extra credit. And then homework is that right column, all in the right side, all the C's. So really there's only 9 questions for homework. 8, let me see. There's only 8 questions for homework. But as I'm walking around and giving people tickets and checking their answers, you can finish that C problem probably before I even get done. Okay, so as I'm walking around, you're trying it, but once you try it, start doing your homework. The test. You're going to see these questions exactly in the test. This question will be on the test. So with this one. So the next one. So you're going to see test questions 4 times before you actually take it. So there's no excuse of like not understanding a question on the test because you're going to see it here, then here, then here, and then on tomorrow's review that you're going to do without me, or like obviously I'll be right there and you can ask me questions. Okay? But I do this every single time. If I show you the test and I show you the review, they're identical. That's tomorrow you're getting this. Okay, so, but then these questions, look at that first one. The same exact question. You're seeing it 4 times before you actually take the actual test. So really take it seriously because this is going to be under test. Okay, let's do this together. Before we do that, I'm going to throw some highlighters at you because I want to make sure that we highlight certain things. You can use a note card on your test, and I'm going to give you a note card again if you choose to. So as we're doing this too, if you're way ahead, you're more than welcome to start writing stuff down for your note card as well. Okay? Your note card will be, I think I emphasize this oral. Okay, so I'm going to give you your note card actually before we start, only because if you have extra time, which some of you will, because you'll finish it really fast, you guys can start like writing your note card too. You're able to use this on the test. You'll be able to use one on the final too. Right? But next semester not so much because the topics aren't as important. Please do not use it. So that is you can use it on the test. You can use it on the test. Questions? Okay. Look. Friday. Okay. So, like I was saying earlier, we're reviewing today, reviewing tomorrow, test on Friday. You know you're not going to be here Friday. It might be a smart idea to take it tomorrow because really you'll be prepared after today to take it tomorrow. Okay, so let's get it. Circle all the rational functions. So rational functions are any ratio as long as it doesn't exclude, as long as you don't include radicals, which is a square root sign, or variables in the exponents. I'm going to highlight 2 things here. Because of this, it's not rational. Okay, so I have to cross that one out. Because of this, it's also not rational. We can't have radicals, nor can we have variables in the exponent. So our answer is A and C. Take a second now and see if you can do the middle one. Try to identify which ones are. But what I like to do is actually cross off the ones that are not. Okay? See how you did. Okay, I will walk around after this one because this one's pretty easy. Okay, you should have circled B and D because this one, it can't be because of the radical, and that one, it can't be. That one was gone, that one was gone. Now that C column, this column all the way at the end, that's your homework. So some of you probably already finished that before I got done talking. Okay, so kind of how this is going to work the whole way through. So about this one. What's really nice about this review is that last period I saw that a lot of people like started to actually understand things after doing it multiple times. Okay, so this one, discontinuities. What makes the denominator equal to 0? What makes the bottom part equal to 0? It's -4, but how Riley got that, if you wanted to write it out for yourself, you would do x plus 4 is equal to 0. Again, some of you might not have to write that step in, I understand that. But a lot of you might, because we got to do to both sides then. Yeah. Okay, so you're right, subtract 4. So x is equal to -4. You have questions on that part. I would do that first. That's important. Okay, getting your discontinuity first is going to help you out because now you say, is the -4 an asymptote or a hole? We have to figure that out. Does this x plus 4 cancel with exactly an x plus 4 on top? No, there's a minus there. So we know right away that this guy is going to be an asymptote and there is no holes. Because look, if you only have one discontinuity, you can only place it in one spot. You can't put it in both. Okay? Then I'm going to write a little note for you. It does not cancel. And that's why it's an asymptote. If it can cancel, it'd be a hole. If we go ahead and do B, and I'll give you I have my ticket card, so I have a little card thingy. Put your initials on it, and then I'll wrap off the credit. You're trying the middle one now based off of us doing that one because they're the same exact problem, kind of. Not 4. No. 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 It's the bottom. The bottom equals 0. Good? Good in there. Yep. And finish before everyone else, then you can do the homework. So the holes is if there's something that's going to cancel and nothing cancels. So it's not. If nothing cancels, it has to be exactly like an x minus 3 on top in order for it to be a hole. Good. 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 You do. Whoa. Come back to me, Con. Good. 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 Yeah. Oh, when you said that, it's that on the bottom. So like because we're all right. So again, the only way for you to study with me is if you're trying them. All right, so the bottom piece, what makes it equal to 0, you guys got 3, and you were correct. Because when you, it's the opposite. You said equal to 0 12. It does not cancel with something on top. When I walked around, I did see, this is why I like to walk around to see like where you guys are. Some people wanted to cancel this. You can't do that. It's got to be exactly an x minus 3 on top for it to cancel. And because it doesn't cancel, it's an asymptote, which means there is no holes. Because remember, there's only one here. So it goes there. You can't have 2. Okay, you can't make one up. Now you have these ones for homework, the C. Okay, this one, do it again. I'm going to use 2 different color highlighters here. I have this guy in blue, and I have this guy in green. Now, what makes the blue group equal to 0? Good, x equals 1. What about the green group? Good, x equals -2. If you're like, whoa, you just skipped a step on me, please write it out. And I will write it out for those that need it. X plus 2 equals 0, and then x minus 1 equals 0. You set the bottoms equal to 0. Okay, so now we got those. Now when we have these, you establish where they go. They both could be asymptotes, they both could be holes, or they could be split up. We just don't know. Okay? Hold on one second. Let's talk about the very first one. We put 1 down, which is the blue guy. Does this blue piece, x minus 1, cancel with an x minus 1 on top? Yes. If you cancel it out, cancel. Remember that the top now becomes a 1. Okay? Because 1 divided by 1 is 1. X plus 1 divided by x plus 1 is 1. Yeah. Oh, it's okay. Thank you. I appreciate it though. So we established that the hole was at that 1 spot in blue. But we have to find out the y. And this is the part where people get confused, is trying to figure out the y piece. So here we go. I'm going to plug in what's left over. So I'm going to put a little note. Plug in x equals 1 into what is left. That's what you have to do here. You take that 1 and you plug it in wherever you see an X. Kind of. Not really. We'll talk about it. I want to make sure everyone wrote that down. So I'm going to draw an arrow because I didn't give you a lot of room here. Maybe put the work right here maybe. And I'm going to plug it in. I have in yellow 1 over something plus 2. So I have 1 over 1. Because that's what I'm plugging in right here. I'm plugging it in right there. Okay, plus 2. So I have 1 over 3, the fraction. Okay, so that, in my opinion, is the hardest part, is just figuring out the whole, the other side. We figured out 1 because it canceled. We figured out 1/3 because we took this 1 and we plugged it into what was left over. Okay, that 1 on top doesn't go away. When you cancel something out, that 1 is still there. That's the harder part. It would be very good. So in green, your asymptote would be -2, and let me explain that again. Because look, when I cancel this and I cancel this green part is still there. And if it's still there, it's an asymptote, and that's where that came from. You can see that. Goes with that. And maybe with my other highlighter, I will highlight the whole piece. Okay, because they cancel. Okay, now, take a minute and try B. Now, when I walked around last hour, I'm feeling it's going to be the same thing. People struggle with this one. But then when we get to number 4, we start to pick up on it. So just trust that it's going to get better, but you have to try it in order to learn. Because I walk around and individually tell you where you went wrong. That's the best part about reviewing together. Tomorrow I won't be doing that. I'll be just sitting up there waiting for questions. Today I will walk around and see how you're doing individually. Take advantage of that. And you have an opportunity for extra credit. Okay. All right, so you're trying B, please. This guy, 3B. Really close. You have 1 over, you're plugging in, not 6, what are you plugging in? Well, look, is that -5, actually? No, it's always the opposite. So it's +5, and then what's this one? Which one cancels? Sure. Yeah, that cancels that. So you plug in -6. Okay, so be careful. So whatever one cancels is the one you're plugging in. Your negative fraction, yeah. 1 over, what number are you plugging in? Not 5. Which one cancels? Yeah, it's 6. And it's not just 6. That's what makes the bottom. 6 or negative. You got a -6. There you go. Now you're getting there. Then you plug in, you notice I cancel this. I get 1 over x minus 5. So then you plug in that -6. I'm going to go over this one unless you're really confident you got it. Anyone? Good, you set that up. Now, to find this whole, you want to put the -6 first, comma something. So we're going to plug it in. There's going to be 1 on top, so 1 over. And then we're going to plug in the -6 right there. So -6. And yeah, you get the answer. You got it. If you're confident, I'm going to check you really quick, but I'm going to go over it because a lot of people are talking about this one and it happened last year too. That's why that's where instead of 1, this should be plugged in. Or this one faster. So when you cancel it, so I'll be 1. So you block it out. Yeah, so you're doing that. The 1 over there. Yeah. There you go. Getting there. Keep going. You're getting there, kind of. Okay, I'm going to go over it because a lot of people, even last period, took a little bit to get used to. So let's go over it again. Your discontinuities, I'm going to color code again. I have a -5, x minus 5, and I have an x plus 6. So I have x is equal to 5 in blue, and I have x is equal to -6 in green. X is equal to... A lot of people just put 6 there. It's not the same sign, it's always the opposite. And if you need to write this out for yourself, please do that. So write these pieces out. Sorry, it's delayed a little bit. Now, here's where people got a little tricked up. In pink, I'm canceling out the 6. I'm canceling out the 6. If you cancel out the 6, the discontinuity that involves 6 is your whole. So that -6 in green is your whole. We just need to figure out the y piece. So -6 comma something. So the moment you canceled, whatever discontinuity went with that one is going to be your whole. And that's why in green, in that pink part, that is what's canceling. So now we plug it in. But when you cancel the top, you still have a 1 up here. Some people forgot that. So I would have 1 over, I'm going to cover this up. This is still gone. Gone. All I have is x minus 5 on the bottom. So I'm going to plug in -6 where I see an x. So -6 minus 5. So I get 1 over -11. I would accept -1 over 11 too. It doesn't matter. Well, if you look here, when I cancel this out, the x minus 5 is still there. Which means that it is a vertical asymptote. So x equals 5. If you like to highlight, this blue piece went with the blue piece up there. Same with the green piece. Okay, they go together. There's a reason why it belongs with the vertical asymptote because it was left over. It was still there. So now what I saw last period was after that, we started to do it a little bit better because the more you do, the better you get at it. So let's do 4 together, and then you're going to do 4B. Okay, so here we go. I have 2 discontinuities. One's here in blue and one's here in green. Hold on, let's not jump too far right now. I have x minus 7 equals 0, and I have x minus 5 equals 0 to help you out. So in blue, what is x? What number? 7. In green, what we got? Positive 5. Do you have a question on that step? Because once you find that, you now figure out where they belong. So let's talk about the 7. This 7 right here. Is it going to be an asymptote or a whole? A whole. And here's why. Because look, they are canceling. So that all goes together. That x minus 7 is going to be a whole. So I'm going to set it up to get ready now. Because now watch what happens. X minus 7 goes away, and x minus 7 goes away. I'm literally canceling it out to a point where you can't even see it anymore. But don't forget there's still a 1 up here. Because maybe then that will make it a little bit easier to see. When I plug in 7, wherever I see an x, you're going to get your answer. So here we go. I'm going to put like a... Oh, actually, I think there's room down here now. Thank God. Okay, so I have 1 over x minus 7. So, sorry, x minus 5. Messed that one up. Plug in that 7 in pink. So I'm taking that 7, I'm plugging it in. So I get 1 over 2. Very good. We're done. Do you have questions on that? I don't know. Is there anything left over? When I canceled everything out, you can see it right now. I canceled it all out. Is there something left in the bottom? Yeah, it's the green piece. So I know that x equals 5 is going to be my asymptote. X equals 5. And if you like to highlight, you can highlight that because it went together. That way when you go back and study, you can see that that's where things are coming from. Okay, you need to try B. And hopefully, I'm hoping when I walk around this time, you've gotten at least one more step better than you did when I walked around the first time. People were a little confused the first time I walked around. Scroll down, yes. Okay, so you are trying this next one here. You got that? 4B. 4B. I do one, you do one, you do it for homework. So if you have time left over, you're more than welcome to work on that homework piece. You got it. See? All you can hope for is that you make progress, and I'm already seeing it in the first person I visited. Okay? Okay, so you're starting to be close. You're right, you plug in 4. What's 4 plus 1? Yes, we should know. Look at that. Oh, yeah, good. You're getting there. Now you plug it back in after your cancel. So, yep, now you're there. You 1 over something plus 1. What are you going to plug in? Yeah, and you're making progress. Good, good, good. You're already getting there. This is huge. This makes me happy. Good. Yep. Good. You getting there? Yep. You're there. You have it. You have the answer. You can't find your error. Yeah, it is the 1. What are you missing? Compare like this answer to that. There you go. Because you see the 1 up there and the 5 down there. You gotta leave it the way it belongs. So if there's 1 belongs on top, the 5 belongs on the bottom. Yeah. You did. You got it. Good job. Did you see it? You got it. Yay! Okay, this is making me super excited. And you are showing some progress. Awesome. What did you get? Good. 4. And then comma something. You gotta figure out what the y is. Mm-hmm. So you would plug it in. So what is 4 plus 1? So 1 over 5. You got it. Good job. Okay, everyone got it. So I'm not gonna go over it. Here we go. Next one. 5A. Now we're back to like the easier ones. You know, the other ones are pretty straightforward. What's up? This is from yesterday. So we're about to do what we did yesterday. We're going to talk about the degrees. So horizontal asymptote, make a note up here. Horizontal asymptote, you need to refer to the chart on day 5 notes. Okay, so like this is where we're going to get all of our answers from. There's a chart that says if the degree is higher on the top, there is no asymptote. If the degree is higher on the bottom, y is 0. If the degree is the same, you have to take the ratio of the numbers out in front. Okay, so what is the degree of the top of this one? 1. What is the degree of the bottom? Is it higher on the top, bottom, or the same? The same. So we have to take the ratio. I'm going to take my yellow highlighter. 8 divided by 4. 2. So y equals 8 divided by 4. So my answer is that easy. Okay, so just knowing that chart. But if you don't like to memorize things, you have a note card for that. You can write yourself a note of those 3 rules. There's 3 rules. Maybe put in a little note for yourself too. There are 3 rules that you need to know. And they're up there. So go ahead and try B. Y equals something. It should be pretty fast. Good, don't forget Y. Yep, good. I like how some of you, when I walk around, you made a note. You said same. Like that makes me like super excited because that means that you understand what you're doing. The degree is the same, so I have to do division. That's how you study for math. You have to write down the things that you know. Good. Good, you're gonna get it. Mm-hmm. So it's gonna be easier than this one. So their degree is a little exponent. Yeah, no, you're good. Good. You get it? Good. You get it? Right. You lie, you okay? One there. There you go. you check. Yeah, you got it. Good. You're killing it. Good. Okay. Y equals 6. Very good job. Next one. What's the degree of the top? What about the bottom? Which one's higher? Top. When it's the top that's higher. So top means that there is none. So this one's none. Okay? So that's a rule. Top means none. And maybe I'll put this up here too. Same from up here is your ratio or division. Either one is fine. So that's the rule. That's rule 1. This is rule 2. If the top is higher, there is none. You're done. Now I'm going to move on to the next one because the other ones are pretty easy. 7a. Let's talk about this one because it's kind of important. It looks a little different. What's the degree of the top? What about the bottom? Yeah, be very careful. There's 2. There's 1 here and 1 here. You have to count them. There are 2 there. You have to be careful for that one. Okay? So, is the degree higher in the top, bottom, or the same? The bottom. And I'll put the third rule. This is rule 3. Bottom means y equals 0. So that's supposed to be a highlighter. Y is equal to 0. So my answer is y equals 0. So up here I did say that there were 3 rules. Here's rule 1, here's rule 2, and here's rule 3. If it's the bottom that's larger, you have y equals 0. That's straightforward. Okay? Alright, let's wrap this thing up and then you will have a good 15 minutes to finish all the C problems. When I was walking around, a lot of you already had that done. Cool. So this one, really focus on paying attention on because this one people tend to get wrong. You just got to be careful with your notation. Determine the behavior of the function and the behavior near the asymptote. Okay, so I'm going to highlight vertical asymptote and I'm going to highlight these 2 pieces. Those are your vertical asymptotes. So when you're talking about your vertical asymptotes, you always have to refer to that graph and see where you're going. The only 2 options here you have are positive infinity or negative. You don't have any other option. So I'm going to highlight with the same color highlighter this -3 because that's where the vertical asymptote is. Now, does anyone remember what this negative sign means? This negative right here means something. It's to the left. Very good. And this positive means right. And you can kind of think of that on the number line. The left side has negatives, the right side has positives. Okay, here we go. On the left side of my highlighted portion, where is the graph going? Good, down. It's going down towards negative infinity. I put that like right by that little end piece there. So that's going to be negative infinity. Okay, now the right side. Here's my highlighted portion. The right side, where is it going? Positive. I'm going to write positive here. Okay, that all goes together. Okay. Now, the next piece is called the end behavior, which is what we did yesterday. So the end. So if you look at your graph, you can kind of see this. Here's the behavior towards the asymptote. Here, look, there's another piece. There's this arrow, and there's this arrow we have to talk about. That's what we did yesterday. They're both going towards a number now. And that number is always your horizontal asymptote, which is what we learned yesterday. So with my other color highlighter, I'm going to highlight my horizontal asymptote in blue. And that's y equals 2. And I'm going to put down here your end behavior. Always refers to your horizontal asymptote. Always. Well, what was my horizontal asymptote again? So then my answer is 2 and 2. You guys were really good at that yesterday. Because look at what happens. This arrow in blue starts to approach 2, like about to touch it. Same thing here. This arrow is about to approach 2. right there. So this arrow is approaching 2, and so is this one, just so that you have as a reference. It's going towards that line. It's getting closer and closer to the line. What's that? Different one. You won't have more than one horizontal asymptote ever. It won't exist. There's not a function that would work that way. Okay? Okay, I want you to take a minute, and I want you to do the middle one because this is a part where I see a lot of people struggle on the test. Is this question right here. Remember, it's the same formatting. I asked you the same exact question. It was exactly like this. Maybe a different graph. So don't assume, don't memorize it in that order. But, because you don't know what the order is going to be, so then I have to refer to it. Okay, so try that one out. Here. I will say, because it's not like right in front of your face, a lot of people got this one wrong last period. What is this y value in blue? It's 0. A lot of people were trying to tell me it was 2, but 2's up here. Okay, so I want to make sure that you use all 0. Yep. Yep. That one. See how on the left side is on the right side. And so it gives us the because that doesn't always So where is that y? What number is up there? Yeah, what number is it? 0. Good. Good. That's why then that's right. Yep. You see how it shoots up towards the line? That kind of looks up there. Yep. Yep. Okay. So let's talk about this. Some people were getting confused. 50-50. If it helps you, I was walking around when I was showing people. I had like my little card covering up a graph. If you get stuck, this means the left side. If I literally cover up the left side, pretend you can't see it with the projector, you can just see just this graph. And that graph is going down. If you cover up the left side, you just look at the right side, you'll see that just this graph is shooting up. And that's why you get negative and positive, and you get zeros for the other. Okay? All right, we're going to do the back page together, and then the rest is yours. You have 8 questions to do for that C column here. Here's putting all of it together. You will have one question like this on the test. So it says identify all the characteristics and then graph. Discontinuities. What makes the bottom equal to 0? So this piece right here. What makes him equal to 0? Positive 4. So x is equal to 4. And that goes together. I'm going to maybe highlight that so it goes together. If you were like, hey, I need you guys to write that out, then write x minus 4 is equal to 0, and that's how we got it. You added 4 to both sides. Now, does that blue piece cancel out with something on the top that's exactly the same? No. So right away I know that it's also a vertical asymptote. I'm just copying it over. X is equal to 4. Does anything cancel at all? No. So I have no holes, which should be super exciting because I know you guys do not like holes. Okay, holes are hard to figure out the why. Horizontal asymptote. That is your degree. What's the degree of the top? What about the bottom? So they're the same. So you have to take the ratio. So here I go. The ratio is 5 over what? 1. So my horizontal asymptote, I'm going to highlight that in yellow, is just going to be 5. So y equals 5. When I pass it down, you need to make sure you have y here. It says, look, find the equation. This is an equal sign. If you don't have an equal sign there, you don't have an equation. Okay, so y. Yep. And so y equals 5 over 1. Okay? That's your degrees. I'm going to draw these two things in. I'm going to draw my vertical asymptote at x equals 4. 1, 2, 3, 4. Here it is. X equals 4. You need to draw these two things in, either with a highlighted lighter or a dotted line. Either one would work out here. And then a horizontal asymptote is at 5. 1, 2, 3, 4, 5. So it looks like this. And I'm going to write this out. Horizontal asymptote and vertical asymptote. So you remember what they are. Obviously, on the test, you would have to write that stuff in, but I'm just showing you that's the horizontal. The blue one is the vertical. Because that's going to help you graph. It's going to help you figure out some things here. Okay. Now, I'm also going to highlight in the same color this next one. It says identify the end behavior. Look at your horizontal asymptote. We did this yesterday. Where are both of those going to go towards? What number? 5. Very good. And I'll show you that when we get that on the graph. The next piece is going to be your vertical asymptote, but we can't really figure that out until we graph it. That's why we have to graph it. Okay, so get out your graphing calculator and let's plug it in. Let's practice. Go to y equals, clear it out. I know that your last class already did it for you, but it doesn't help you when they do it for you. Press the green alpha button and then y equals and press enter. Now let's just plug it in. 5 parentheses x minus 1, was it? Okay, and then x minus, what's on the bottom? X minus 4. You can use parentheses, you don't have to on the bottom. And when you press graph, you can see like what it looks like. Here's the shape of it. So I'm going to put it side by side so you can see when we sketch it, like how you would graph it. Use your asymptotes as like a guideline. Look at, you can kind of see like that left graph goes on the left side. So I'm going to draw something like this. This would be perfect, but boom, okay? I like to make my noises when I draw these things. And on this side, it looks like this. Boom. Doesn't it be beautiful? It just has to look kind of like it. Okay. Last part here. Last two parts. On the left side. This is the left, remember. Left. What makes the left, or where's it going? Positive or negative? Here's the left side. Where is it going? Negative. Very good. What about the right side? Positive. Okay, the right side of the blue line. Here's the right side of the blue line. That arrow is pointing up. That's how I know that. Your domain is your discontinuity, and we're done. Or you can go left to right. Left to right. It's right. Negative infinity. I stop existing at the blue line, which is going to be 4, and 4 to infinity. So I have negative infinity to 4, negative infinity to 4, and then 4 to positive. And I'm going to highlight one last thing in blue because your domain is affected by your vertical asymptote. So that 4 that was